Howdy, this is the solution to the physics extra credit question for Physics 218 with Dr. Usabi. Over here, these are the variables that we know. We know that the mass of the ball is 0.17 kilograms and that the radius of the ball is 0.028575 meters. The time, we call the time that the cue struck the ball 0, and the final time that the ball started rotating the other direction, 3.93 seconds. These times are taken when we slowed down the video, so after we multiplied it by the scale, we got 0.0614. That's the actual time. So the initial angle of the ball was 1.48 radians, and the final angle of the ball was 1.57 radians. Next, we move on to the equations that we use to solve this question. We have the equation for theta final, which is theta initial plus omega t plus half alpha t squared. Then we have that the sum of all external torques equals the moment of inertia times alpha. And we have the moment of inertia of a solid sphere, which is 2/5 mr squared. And we have the force of friction, which is mu mg. Alright, so moving on to the actual questions or the actual solutions. First thing we had to do was finding the angular acceleration. Using the first equation we wrote down, which is theta final equals theta initial plus omega t plus half alpha t squared. We know that omega t goes to 0 because there's no initial angular velocity. Our final theta was 1.57 and our initial theta was 1.48 plus half alpha, and then our final time, which is 0.0614 squared. After subtracting 1.48 from 1.57, multiplying by 2 and dividing it by the square of 0.0614, we get 46.3 radians per second squared. Our second step would be finding mu, or the coefficient of friction, up the pool table. We use the sum of torques equals the moment of inertia of the sphere multiplied by the angular acceleration. So the sum of all torques would be the radius times the friction force, and the moment of inertia is 2/5 mr squared multiplied by the angular acceleration alpha. So r's over here cancel out, as do the ends. So then what you do, to find mu, all you have to do is take 2/5 r alpha over g, which is 2/5 over here, and then r, then alpha over g, which will leave you with coefficient of kinetic friction of 0.054. Thank you.